Take a moment to read Unit 6, Lesson 5, Problem 3, Part 2, Back and Forth. In this activity, students are asked to answer two questions. First, they must explain how they will rewrite the equation into circle form. Then, identify the center and radius of the circle. Previously, students have identified the center and radius length of a circle when given an equation in circle form. In addition, the two activities in this lesson gave students the opportunity to look at patterns in expressions. These expressions were written in squared binomial or perfect square trinomial forms. Let's start by identifying these patterns that students looked at in the first two activities of this lesson. First, we need to identify what is a squared binomial. A squared binomial is a polynomial with two terms. So in this case, in this example, we have a term of x and 6. Those are my two terms to make my binomial. And as you notice, that binomial is being squared. Students started to look at the patterns that would happen to go to a perfect square trinomial. When I say trinomial, it means that it has three terms. Notice this one has x squared as the first term, 12x is the second term, and 36 is our last term. We're going to talk about the perfect square portion of it right now. Let's think back and make a connection with something that we have previously done in Algebra 1. We have done the area model. So I'm going to show you the area model about how these numbers came about and the pattern that students started to notice. So first of all, let's address in a squared binomial. Remember that when we square a value, or in this case, a binomial, it means that we're really doing x plus 6 times x plus 6. So when I go to make my area model, I'm going to draw a 2 by 2 area, and I'm going to have a length of x and 6 on the top and x and 6 on the side. So remember, when we're doing the area model, we are finding the area of each one of these little pieces, right? So if I'm finding the area of this first part, I'm doing x times x, which would give me x squared. To get this one, I would do 6 times x, which would give me 6x. Down here, I would do the same thing. X times 6 would give me 6x. And then in this last box, I would be doing 6 times 6 to get 36. Now, here's where some of these patterns come in. The first thing that I notice when I say perfect square trinomial, the perfect square is coming in our first and our last terms. So I noticed that my first box, I was multiplying x times x, or whatever my first term was, I was really squaring that value. Okay, so this is a perfect square, x squared. Notice that I also have this bottom box in the bottom right. I'm doing 6 times 6 to get that value, and 36 is a perfect square, right? So students start to notice this pattern that's happening. Something else that's unique, remember this only works for squared binomials, is that on my diagonal, or these two other values, notice that they're exactly the same. And remember, when we start to simplify these polynomials, we want to make sure that we're combining like terms. So 6x and 6x are going to be like terms. So if I were to add those together, I would end up getting 12x. And notice that's my term that I see here in my perfect square trinomial. One of the patterns that we specifically noted during our activity previous of this one is that to get this value in the middle, we can do 2 times our two values that we have in our binomial. So we're really doing 2 times 6 times x. And we know that 2 times 6 is 12x. Okay, the other pattern that we started to notice is, again, we can square our last term. So 6 squared is going to give us that 36. And we're also going to square our first term. So x times x is going to give us x squared. So notice, this is really the pattern that we started talking about and recognizing during our first activity. So let's go ahead to the question. So they give us this equation. Notice that this equation is very long. It is not in the form of a circle. This is how our equation of a circle, this is the best way to look at an equation of a circle. Notice that those are square binomials. So we have to figure out how are we going to get this long equation to end up being in this equation of a circle. So hopefully the first thing that you notice is that I kind of have two sets of trinomials. I have this one that has x's, and then we also have another one. These ones have y's. And notice that I also included that constant at the end because I'm talking about trinomials. So I had to have three terms. So the first thing that I would want to do is figure out how can I rewrite both of these as squared binomials. The second thing that I would need to do is if I take a look, it says that I need to do r squared. And notice this one gives me just a constant value of 64. So I would need to figure out what number could I square to get 64. So if you want to take a look, again, you can pause this. This is how we would expect students to write to us about what steps they would do to help rewrite this equation. Now I'm going to continue on to do part B. I want to just remind students or remind parents about our equation of a circle. I know that we saw some different letters, H and K. Well, H and K represent where the center of our circle is. And then there's also R, and that represents the radius of the circle. Now, we kind of set out for part A what we were going to do. We were going to try to change these trinomials into squared binomials. So I like to put parentheses around my trinomial. So again, we said that in our pattern for trinomials, that our last term is going to be squared. So I need to think of what number could I square to get 9? Well, in this case, I know that I could either pick 3 or I could pick -3. Now, I need to know what should I pick? Should I pick positive or negative? How I'm going to tell is based on my middle term. Because remember, we said that in order to get this middle term, we were going to have to do 2 times one of these numbers and then times our first value. So because this is a positive 6, I know that I have to pick positive 3 because 2 times 3 is going to give me 6x. So when I write this out as a squared binomial, it's going to look like this, the quantity x plus 3 squared. Now, don't forget, you can always go back and do the area model to make sure that when you simplify it, it does give you x squared plus 6x plus 9. We're going to do the same thing over here with this one. Now, I can do a similar idea, but let's say I don't know what gives me 25, right? 2 of the same number that multiplied together. I can take the square root. So if it's not something that I know right off the top of my head, I can take the square root of that number. So square root of 25 is 5, or remember I could always do -5. I have to determine which one I'm going to use based on my middle term. So let's go to the middle term of this trinomial. I have -10y. So I need to think about 2 times which one of these numbers is going to give me -10. So notice this time I would have to pick a -5. So when I write this one out, I'm going to write y minus 5 squared. Again, you can always go back and do the area model to make sure that this squared binomial that you found really does give you a perfect square trinomial. Now notice I have to put a plus sign between those. And remember, our last step was we need to figure out what can I square to give me 64. And again, if I'm not sure, I can do the square root of 64. 4, and that's going to give me 8 or negative 8. Now, in this case, because I'm talking about the length of the radius, I do not want to pick a negative number because when I'm measuring lengths, I do not have negative values. So in this case, I'm going to pick 8 squared. Okay, the second part of this said, or actually it was the only part, it said, what are the center and radius? So I first had to get it into my circle form. Now I can find my center. So again, my center is based on my h and my k value. So I first need to solve this binomial, and I need to figure out what would that equal. So again, the easiest way is to set this equal to 0 and to solve it. So I'm going to subtract 3 on both sides. So I figure out that first term needs to be negative 3. Okay, sorry about that. It should be x equals, x equals negative 3. Okay, then I need to figure out my k value. So again, my k value is now coming from, sorry about that, this one. Okay, so I'm going to do the same thing. Y minus 5 equals 0, and I'm going to solve that by adding 5. So I get y equals 5. So I know that my center is coming from these two values. The x coordinate of my center is negative 3. The y coordinate is positive 5. When I go to look at my radius, notice that it's whatever this value is squared, but I don't really want the squared, I just want the number. So in this case, my radius is a length of 8.